Example 3, bone density test using StatCrunch. A bone mineral density test can be helpful in identifying the presence or susceptibility to osteoporosis, a disease that causes bones to become more fragile and more likely to break. The result of a bone density test is commonly measured as a Z-score. The population of Z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these test results meet the requirements of a standard normal distribution. Now, the graph of the bone density scores is shown in the figure below. And you will see that a randomly selected adult undergoes a bone density test. We want to find the probability that this person has a bone density test score less than 1.27. So note that the following are the same. Because of the aforementioned correspondence between probability and area, probability that the bone density test score is less than 1.27. The shaded area is shown in the figure above, and so we need to find the area in the figure to the left of z equals 1.27. So here are the instructions on StatCrunch. Okay, so we're going to open up StatCrunch, and it says we're going to click Stat at the top of the menu, and then we're going to go to Calculators, and then from the drop-down menu, and then we're going to select Normal, since we're looking at the normal distribution. So here you can see what this graph looks like. Now, in the calculator box, we want to make sure that the mean is 0 and the standard deviation is 1, which it is. And now, since we are looking for the area to the left, we want to make sure that the inequality is here showing less than or equal to. Now, instead of having a z here, they have an x here. Now we're going to enter the score here of 1.27. So when you see that score, you're going to see what is shaded, which is very similar up here. And then we're going to get the following area, which is, we're going to click Compute. Now, we want the area below 1.27, and StatCrunch provides the cumulative area from the left, so we can see that the desired area is 0.8980. So here is that display. So down here you will see that we get 0.89795, and rounding that to 4 decimal places gives us 0.8980. So because of the correspondence between area and the probability, we know that the probability of a z-score below 1.27 is 0.8980. So let's take a look at the interpretation of this. The probability that a randomly selected person has a bone density test below 1.27 is 0.8980, shown as the shaded region. Another way to interpret this result is by multiplying 0.8980 times 100%, and we would conclude that 89.80% of people have bone density levels below 1.27.